Good morning everyone, and welcome to today's worked exam answer video. Today I'm having a look at a calculation that involves using Avogadro's constant, and we're being asked to work out how many protons there are in 6 grams of nitrogen gas. As you can see, this is a multiple choice question, and my advice whenever you've got multiple choice questions where you can answer the question without having to look at the options, that would always be my advice. And for calculations we can do that because we don't need to be looking at what the options are here. We just need to work out for ourselves how many protons there are in 6 grams of nitrogen gas. Then once we've got our final answer, we can then see if it matches with one of the options. And the reason that I say that is because AQA examiners and the people who write the scripts, they know that students will get so far through this calculation, will check to see if there's an answer that matches, and they'll go with it. And at part way through this calculation, the answer of A will pop up, but A is not the right answer. So if you can avoid looking at the options until you've got your answer, then you can cross-reference them. I think that's a little bit safer because you're less likely to be swayed by the options that are there. Now, obviously, we can't always do that because there'll be some multiple choice questions that say, which of these 4 statements is correct? You'll have to read all of the statements, there's no way around that. But for certain questions, we can answer them without looking at the options, and that would always be my advice. So this is an AQA multiple choice question, which could appear on either an AS paper or an A-level paper. It's first introduced in the amount of substance topic, which you'll meet in year 12, but of course in year 13 you need to be able to answer questions covering the topics from both years. So this could also appear on an A-level paper on the paper 3. So key pieces of information from this question is the fact that we're being asked how many protons there are, so not how many atoms or how many molecules, we're asked how many protons there are in 6 grams of nitrogen gas. And then handily, AQA will always give us Avogadro's constant as a part of the question if we need to use Avogadro's constant. And you might get a really similar question if you're studying the OCR specification, but with the OCR exams, Avogadro's constant is only given in the data sheet, and you would need to know when you would need to use Avogadro's constant and then go and look up what it is. So in my opinion, that makes the AQA questions a little bit easier because they will give you Avogadro's constant if you need it. You don't need to go looking for it. But if you are studying OCR, you still might get a question like this. You would just need to know to look up Avogadro's constant. So in terms of, I guess, the first step with a question like this, we've got a mass and we can use MR to work out moles. And Avogadro's constant is used as another way of working out the number of moles that we have for a particular substance. So we will hopefully all be really familiar with moles is equal to mass divided by MR, but we can also work out moles by doing number of particles divided by Avogadro's constant, where the number of particles could be number of atoms or number of molecules, number of ions, etc, etc. And we're going to need to use the second way of working out moles, rearrange it to get number of particles, and then once we know the number of nitrogen molecules, we can then figure out the number of nitrogen atoms, and then if we know how many protons are in one atom, we can work out the total number of protons we will have in all of those atoms. So that's my plan for this question. Now, nitrogen gas, the first thing we need to know, and this again is why this is a sneaky question, they could have chosen how many protons are in 6 grams of anything. Now they've chosen nitrogen gas because they need you to know that nitrogen is diatomic and thus exists as 2 atoms joined together, so N2 molecules. If you were to just use N, obviously you're going to get the answer wrong, and I imagine that's where one of these other options comes from, because again, the AQA examiners and the people who write the papers, they will choose answers that are wrong that follow common misconceptions. So that's the first thing we need to recognise, is that nitrogen is N2. So when it then comes to working out the moles of the nitrogen that we have in those 6 grams, we're going to do the mass, which is 6 grams, divided by the MR, which won't just be 14 because it's diatomic, it's going to be 28 because we're going to have 2 nitrogens. Each nitrogen's relative atomic mass is 14. So that's the first thing I'm going to work out on my calculator, and I get an answer of 0.214, and I'm going to write all my answers down on here to 3 significant figures, but I'm going to leave the whole calculator display kind of going forwards with the calculations. So that is how many moles of nitrogen we have. Now, as I said, another way that we can work out the number of moles is number of particles, and I'm purposefully using particles as a very generic overarching term because what specific particles we're talking about will depend upon which substance we're looking at. And then we would divide the number of particles by Avogadro's constant. Now, Avogadro's constant is the number of particles within 1 mole. So if the number of particles we had was the same as Avogadro's constant, we'd get 1 mole here, which is a nice way just to check that you've got your equation written out the right way. So if I therefore want to work out the number of particles, I would rearrange this and do moles, which we have, times by Avogadro's constant, which we have. So that would be my next step. So number of particles equals the 0.214 for the number of moles of nitrogen gas we have, times 6.022 times 10 to the power of 23. And when I do that on my calculator, I get 1.29 times 10 to the 23. Now that, if you thought that that was the end and you were just thinking about number of particles rather than number of protons specifically, then you would probably go with option A. And that's where it's really important that you are certain you finished your calculation before you check, because with multiple choice options, and I totally understand this, if you get an answer that is there, that feels like quite a relief and quite a, oh my god, yes, I've got an answer that I can choose. But that would be the wrong answer to pick in this question, because that tells me that 1.29 times 10 to the 23, that is the number of N2 molecules. Whereas we want to know how many protons there are. So we've got some more steps to do. Now, we can do this in one of 2 ways. We can either work out how many nitrogen atoms we have if we know how many N2 molecules we have, and in 1 molecule there are 2 atoms. We can figure that out, and then once we know how many atoms we've got, we know how many protons there are in 1 nitrogen atom, because we can look for the atomic number on the periodic table, which is 7. And if we know how many atoms we've got, we can know how many protons we have in total. Or we don't need to go via atoms, because we know in an N2 molecule there are 2 nitrogen atoms, so we can just go, well, in 1 molecule there are 14 protons, and do it that way. I'm going to do it via the atom route first, because sometimes it can prove a little bit tricky to know how to go from molecules to atoms and then atoms to something else. And like I say, it comes down to, in 1 molecule there are 2 atoms, so the ratio is 1 to 2. So if I then want to know the number of N atoms, and I know how many molecules I have, there is 2 atoms for every 1 molecule. So therefore, if I know how many molecules I've got, I'm going to have to times that by 2 to figure out the total number of nitrogen atoms, which would give me 2.58 times 10 to the power of 23. So using that ratio of 1 to 2 times the number of molecules we have by 2, and we'll get the number of atoms, which is exactly what I've done there. So this number here, sorry, is the number of singular nitrogen atoms. And then we're trying to work out how many protons there are within this particular sample. So to then do the number of protons, again, if we know the number of atoms, which we do now, 2.58 times 10 to the power of 23, again, that we can think about the ratio. So for every 1 atom, there are 7 protons. So if I know the number of atoms, in order to get the number of protons, I'm going to need to times that by 7. And that should then give us the number of protons we have in those atoms. And if I times that by 7, I get 1.81 times 10 to the power of 24. And that is how many protons we should have in our sample of nitrogen gas. Now, thankfully, that is one of our options. And I've gone for 3 significant figures. They've gone with 2, which is fine, because my answer, if I was to give it to 2 significant figures, would be 1.8 times 10 to the power of 24. So my answer here is C. As I said before, try not to check the answers too soon, because otherwise you probably would have put A. Hopefully, in terms of going from the molecules to the atoms to the protons, that makes sense as a method. So molecules to atoms, there's 2 atoms in every 1 molecule, so we can use that as our ratio. Once we know the atoms, there are 7 protons in every atom, so we times that number by 7. Hopefully that makes sense. Hopefully you can see how knowing the 2 different ways that we can work out the number of moles is useful in questions like this, because we can figure out the moles, then use Avogadro's constant to get the number of particles, and needing to remember that nitrogen is diatomic. Now, there's a few different multiple choice questions that look like this. There's one for propane, similar sort of thing. I don't think it's protons they're asking you for there, but it's propane and they give you a mass in kilograms. Mass should always be in grams, but again, it would be the same technique as here. And if you do spot any other questions like this that you want to check out with me, you can send me the question and I'll do a worked answer for you, or you can leave me a comment on the video briefly explaining what the question is, and again I can do a video for you there. If you want to send me the specific question, my email address is missgtutoringandresources@outlook.com. More than happy to receive emails with questions on anytime. Thanks so much for watching, guys. Hope you found it useful.